Hello friends, welcome back to our YouTube channel. So we are solving mathematical physics written by H.K. Das, and today we are going to solve question number 7 of Fourier series, that is of exercise 11.2. So in this question we have to represent the Fourier series for the function mod of x in between the limits minus pi to pi. So students, and finally we have to deduce this relation also, as we have deduced it in the last video also for the another question. So students, just see the value of the function is mod of x. That means the whole function will always be positive. It will not depend on the value of x. Either the x is negative, then only this value will be positive. If x will be positive, then the function will also be positive. Okay, it means to say function will always be positive. But here limits are from minus pi to 0. So students, we can divide these limits, that is the value of x we can divide minus pi to 0 only, and the second limit will be from 0 to pi only. Okay, because in this region, if I will put x equals to any value in between these ranges, then this value will be, the function will be positive only. If I will put in between these, then x should be equals to minus x, because only then the whole function will be positive. Because here I can write it just like that, f of x equals to minus, and the value of x is, just suppose that, minus pi by 2. Okay, so this whole value will become plus pi by 2 only when I will put x minus in front of x. Okay, and one more thing, here this question we can discuss in our next exercise also, that is this question is an even function, or this function is an even function, and but we are not going to solve this by the even function and odd function. We are going to solve just by the simple methods over there as we are solving. Okay, because even function I have not started till now. This will be started in the next exercise, that is in 11.3. so I will put it over there. Okay, so the value of a naught I will calculate by putting these two sub ranges, that is from minus pi to 0 and multiplying 1 by pi here also, and minus pi to 0 and mod of x. So I will put here minus x. The value of the function will be minus x only here, as minus x I put it over there. Then integrating this, then 1 by pi, and putting limits from 0 to pi x dx. Okay, so this value will turn into, that value will turn into 1 by pi, and this value will be minus, I will put outside, then this value will turn into pi square by 2, x square by 2. Now put the limits from minus pi to 0, then plus 1 by pi and x square by 2. Now put the limits from 0 to pi. So this value will become minus 1 by pi, and inside 0, that is x only. So 0 minus pi square will be pi square only by 2. Okay, plus 1 by pi, inside pi square minus 0, so this value will be pi square by 2 only. So pi will cancel out square, and here also pi will cancel out pi, and this minus will be add on. So this value will turn into minus pi by plus pi by 2, and again this value is plus pi by, that is only minus pi only, that's only, no, that is also minus pi by pi square by 2, and that is pi square by 2, but the limits are just like that. So this value is pi by 2, and this value is also pi by 2. So this whole value will become equals to, just by adding these number we will get pi only, and the value of a naught by 2 will be pi by 2 only. Okay, so we got the value of a naught here. Now we have to calculate the value of an. Now putting the same formula, I will put 1 by pi, integrating from minus pi to 0, minus x cos nx dx, plus cos nx dx, plus 1 by pi, and integrating from 0 to pi, and x cos nx dx. Okay, so integrating this value we will get minus 1 by pi I am taking outside, and inside x cos nx will be, x I will put as it is, and cos nx will be sin nx by n only, then minus I will put, and differentiation of x will be 1 only, dot integration of sin nx by n will be minus cos nx by n square. Okay, now put the limits from minus pi to 0, then adding plus or 1 by pi, and in integration of x sin nx will be same only, so I will put it over there. Similarly, x sin nx by n sin nx minus minus will be add on, so this value will be cos nx by n square. Now putting the limits from 0 to pi. Okay, so x sin nx will be 0, x sin nx will be 0, as we know that sin 0 is 0 and sin n pi will also be 0. So these, by putting these limits, we will get it 0. So from here we will get 1 by minus 1 by pi bracket start cos nx by n square. Now putting the limits from minus pi to 0 and plus 1 by pi, and this value is cos nx by n square. Cos nx by n square. Now put the limits from 0 to pi. Then we will get the value just like that, minus 1 by pi and cos 0 minus cos n minus n pi. So this value will be cos n pi only divided by n square, then plus 1 by pi, and inside cos n pi minus cos 0 divided by n square. Okay, so this value will turn into minus 1 by pi inside 1 minus 1 power n divided by n square, and plus 1 by pi into minus 1 power n minus 1 divided by n square. So this whole value will turn into, by solving it, minus will add on, so 2 into minus 1 power n and minus 2 divided by n square. So I will take 2 by n square common, and inside minus 1 power n minus 1. Okay, so this is the value of an. Okay, similarly we will get the value of bn, and we know that bn is 0 as this is the even function, but furthermore for our satisfaction we will calculate it. Bn will be minus pi to 0, that is 1 by pi here also, and f of x, that is minus x sin nx dx. Okay, plus 1 by pi integrating from 0 to pi x sin nx dx. Okay, so this value will this value will turn into minus 1 by pi, and integration of x sin nx will be, x I will put same as it is, and integration of sin nx is cos nx by n, that is minus cos nx by n. Now put minus over there, differentiation of x will be 1 only, and integration of minus cos nx will be sin nx by n, so by n square it will become. Now putting the limits from minus pi to 0 plus 1 by pi, so x sin nx integration is there, so I will put same value as it is, so this value will turn into x minus cos nx by n, and minus minus will add on, so sin nx by n square. Now put the limits from 0 to pi. Okay, so minus sin nx by n square will be cancelled out, and this value will also be cancelled out, as sin 0 is 0 and sin n pi is 0 also. Okay, so this value will turn into, that is minus sign, so minus sign will be outside, so this value will turn into x cos nx by n pi, and this value is minus x cos nx by n pi, but the limits are different. In this, that is from 0 to pi, and in this, that is from minus pi to 0. So I will put the limits 1 by n pi I will take outside, and inside x is 0, so this whole value will become 0, minus minus pi and cos n pi by nothing, minus pi cos n pi minus 0. Okay, by n pi only, so pi will cancel out pi here, and here pi will also cancel out pi, so this value will turn into minus cos n pi by n, and this value is also minus cos n pi by n only. So this value, one more thing here, this value will be cancelled out only. I think somewhere we had done one mistake, that is minus x, where we put it minus x over there. Okay, then after that x cos nx, so this is 0 minus pi. Okay, so students, this value was positive. Okay, so this value will be positive only, and this whole value will become 0. So we got the value of a naught equals to pi, so a naught by 2 will be equals to pi by 2, and we got the value we got the value of an equals to minus 4 by n square pi. That is just like that. Okay, that is 2 bracket start that is 2 bracket start minus 1 power n minus 1 divided by n square. Okay, so students, here to get the value of an, if I will put n as an even number, okay, so minus 1 power n will be a positive term, so this whole value will be cancel out, so an will be 0. If n is an odd term, then minus 1 power n will be negative only, so this whole value will become an equals to minus 4 by n square pi. So I wrote it directly, but answer is same as I had explained you. So now that's the time to write the Fourier series, and Fourier series will be a naught by 2, that will be pi by 2, minus plus an cos nx will be 0, and plus bn an is minus 4 by n square pi cos nx, so cos nx, and here summation is also there from n1 to infinity, and that is for only odd number of terms. So this value will turn into pi by 2 minus 4 by pi, I will take common outside, and inside my cos nx by n square. So this value will be cos x by 1 square plus cos 3x by 3 square plus cos 5x by 5 square up to dash dash dash. Okay, and for even terms that is 0, so this is our required answer. But finally students, we have to deduce this relation also, that is pi square by 8 is equals to this. So here we know that for the value of x at equals to 0, I can write it just like that, because x is the only function of discontinuity over there. So I will put f of x, that is mod of x, equals to 0. So this whole value will be equals to pi by 2 minus 4 by pi, and inside this value cos 0 by 1 square plus cos 0 by 3 square plus cos 0 by 5 square up to dash dash dash. So my pi by 2 I will bring to that side, so minus pi by 2 will be equals to minus 4 by pi, and this value will be 1 by 1 square plus 1 by 3 square up to dash dash dash. So minus will cancel out minus, and this value will finally become pi square by 8 equals to 1 by 1 square plus 1 by 3 square up to dash dash dash. So thank you, have a good day.